Hey folks, welcome back. Physics 11, Pen High with Mr. Heinrich. We're going to start chapter 4. Nice short video for you here. The first little bit of chapter 4 is going to feel a lot like something you've seen before. It's going to feel a lot like kinematics. We are talking about gravity a lot in this chapter. And I want you to always think about sort of the rate at which gravity pulls things down. So we're going to start by looking in this lesson, again, nice and short, just free fall. And we've had this discussion already in chapter 2 at the kinematics. We're just going to let things drop. Now, in some examples, you'll see that we actually do just drop things. Like we're standing on the edge of a building and maybe we've got an egg and we want to drop that egg down off the side of the building. But letting things drop could actually just be like throwing something in the air as well, though. That's still letting it fall down, right? Or throwing it down, it's still falling down. So really what we're looking for is letting things fall out of the air. We may just drop it, we may throw it up, we may throw it down, but there's going to be nothing else that's like helping it go up or down. There's no little rocket packs on our eggs or something like that. No parachutes sort of exerting a backwards force to slow down gravity. So with gravity itself, we've had this discussion too already, that I need you to always remember that all objects, doesn't matter if they're big or they're small, if they're heavy or they're light, regardless of their mass, in the absence of air friction, that's a pretty big asterisk, right? So we're not talking about feathers falling down or anything like that. We're talking about if you wanted to drop a feather or a piece of paper, you got to crumple it into a really tiny ball so that air friction is negligible. So if we think about shapes or items that fall without air friction being an issue, then all objects accelerate downwards at 9.8 meters per second squared. Golf balls, pianos, cars, rockets falling out of space, right? All of it, little, big, it doesn't matter. That could also be a negative 9.8 if you're going to go and put it in a kinematics list like we did back in chapter 2. So it's either 9.8 meters per second squared down or negative 9.8. So what we're going to do in this chapter is we're going to break the notes into two parts for the first few lessons. We are going to look at some examples where we assume that we're on the surface of the Earth and gravity is 9.8 meters per second squared. And then we'll also switch things up a little bit in the first few lessons and then use some examples to find gravity. Maybe we're testing that. Maybe we want to make sure, we want to document that gravity is actually 9.8 meters per second squared at our location. So the first example, we are going to let something free fall, let it drop. And it's going to look like that. So we're standing on the edge of a 20-meter tall building or cliff. We want to find the final velocity of this little ball at impact. We are going to launch it upwards at 14 meters per second. So still, like I mentioned earlier, we are letting that ball drop, but that doesn't necessarily mean the initial velocity is 0. So really all we're going to do here, this looks a lot like what we saw back in chapter 2. We're just going to play around with the VifDat list. We're going to make a list of our variables, pick a kinematics equation, done. Like it's that quick, it's that easy. So looking at this, we've got an initial velocity of 14. Final velocity is our question mark. That's what we're looking for. You do have to be a little bit cautious of this displacement because the thing is falling that far. It's falling 20 meters, so that needs to go in as a negative. We know acceleration is pulling things downward, so acceleration is going in as a negative 9.8. And it looks like we forgot our stopwatch. So time is the one that gets the x. Head to your formula sheet, pick an equation that doesn't involve time. There it is right there. Go ahead, plug your numbers in. Pretty straightforward. This part's easy, right? Feel free to just scribble it down. I don't even know if you need to calculate it yourself. I trust that you'll get this part. Now, I guess there is a small little issue here. You're going to get VF squared equals 588. You're going to square root that. You're going to get an answer of 24 meters per second. But we probably should add the negative sign onto it because the object is falling downwards. And we were really picky about the negative sign here with the negative 20. We're picky about the acceleration at negative 9.8. And here we should be picky also about that final velocity being in the downwards direction. Sometimes students will say, but when you square root something, it's positive. Well, it's actually plus or minus, right? We just ignore that a lot of the time. So here we actually do want the negative version. I'd love for you to go and take the negative version of that and tell me, hey, the object is falling down at 24-ish meters per second. So there's the first example of only 2 for this video. The second one, let's use freefall to find gravity. So maybe you're doing a little experiment. You want to prove that gravity is 9.8 meters per second squared in your location. So we're going to take an object. This time we are just going to let it drop. We're not going to throw it up or down, but just let it go. Initial velocity of 0. We're on top of an 85-meter tall building or cliff. And we did have our stopwatch this time. It took 4.2 seconds for that object to hit the ground. So this one we're going to do our VIF-DAT list. And I'll sketch this one out with you. VI, VF, DAT. The initial velocity is 0. We've got a displacement. Remember, it's falling down. It's negative 85. Time is 4.2 seconds. And this time it's actually, gravity is an acceleration, right? That's what we're after. So we don't have our radar gun. We don't know how fast the thing's going when it hits the ground. We need an equation that doesn't have VF. So if we go to our formula sheet, D equals VIT plus 1/2 AT squared. Kind of nice here because that initial velocity at 0 is going to allow us to do this. 0 multiplied by t, gonzo. Again, I see that mistake a lot where students think that 0 multiplied by some number is still some number. Now, let's just get it out of there. In this case, we're solving for acceleration and just for fun. You could go and plug the numbers in and just run the numbers. I'm going to talk about rearranging this equation and then plugging the numbers in. This is actually something that you'll do more in Physics 12. I won't say if you decide to take it, I'll say when you decide to take it. Let's just rearrange the equation first and then plug the values in at the very end. So maybe we could get rid of that 1/2. We could multiply both sides by 2 times 2. That's going to let us cancel the 1/2. We're left with 2d equals AT squared. And now we're simply going to divide by t squared. So something kind of different just to practice that. We end up with that equation. A equals 2d over t squared. So now we can go and plug the numbers in. 2 times negative 85 all over 4.2 squared. Now, you can probably assume that you're on planet Earth for these. So we're looking for a number close to 9.8, but I want you to think like me. And that's maybe a scary thought, but think like a teacher. No, it is a scary thought, let's say that. I don't want the answer always when we're solving for gravity to just be 9.8, where you could just put a bunch of gibberish on the page and then just randomly throw in a 9.8 in the little answer box. So don't be surprised when you're solving for G in this chapter on worksheets, on the chapter 4 test, if you get answers that are 9.8-ish, right? If you go to that 2 sig figs even, it's probably going to be something 9.8-ish. And that way I'm keeping you honest. You do actually have to do a little bit of math. You can't just make up a bunch of stuff and then put a 9.8 in the end. And there you go. There's an example. So this one we get negative 964. Negative 9.64 meters per second squared. Now, that doesn't mean that we're in some place where gravity is all wonky. It could just be uncertainty, right? It probably is uncertainty, which we didn't deal with in this question. So that's what the first lesson looks like. Pretty darn easy. It's like kinematics. using acceleration at negative 9.8, or solving for g, solving for acceleration. So give worksheet number 1 a try, questions 1 through 6. If you have any trouble with that, please get in touch with me.